And before GPS was popular, what was used and still is used for different reasons today were these cell phone towers and the signal that your phone receives from these towers. So you might know that if you are very close to a tower, then you have this high signal here. But if you're going to move away, like farther away from some kind of tower, then your signal decreases. And actually there is a formula for how it decreases, and this is the one I found online. So it has to do with the radius. This big R here is going to be the maximum radius that the cell tower is allowing you, and somehow depends on logarithm based on that. But anyway, you can see that if you reformulate this based on the signal strength, you can figure out this R, the small r. Okay, doesn't work. Maybe like this. Yeah. So this small r, you can figure it out if you know this one. And you know the signal because you see it all the time on your top of the phone. What your phone actually says is the strongest signal. So it says the signal to the nearest tower or the more powerful tower. But actually inside the phone knows to all possible towers that it sees. All right. So, okay, now it starts to work. Yeah, so you know the radius, you know how far you are from one tower. That means that basically you can be anywhere around this circle, if you know this R. And one tower is not enough to do the positioning. You need another tower. Now from this other tower you will have some other radius. It can be the same, but it's very unlikely, so it depends how far you are from both of them. So you can see now that with two towers you can basically be in two locations. Like it's either one or the other. And how exactly you find these two locations, you actually have to solve a system of equations. Does anybody remember the circle equation?
Yes.
Okay.
X squared plus EX squared equal to the radius? Yes.
Yeah, so this is the radius, okay? Could you tell me the equation for the first circle, this one here? Because I have some exact numbers in this example.
X minus 1 squared, y minus 1.
Right? Yeah. And the second one, okay. If you solve this system equations so that both of them are true, and that's going to be your homework, I think, you will find these two different locations. If you add another cell tower there, then one of the locations disappears, and then you have accurate position. Or not, because these signals are affected by a lot of things. They travel slower sometimes through forest. They might be blocked by walls, weakened by walls. So you get a weaker signal, therefore you think that the R is different. You only have the signal, you don't know what's blocking it. This is a problem with this kind of cell tower positioning. It's not entirely accurate. So your location becomes a bit fuzzy. How accurate is this cell tower positioning? It depends very much about where you are. If you are in a very populated place with many towers that you can use to pinpoint this location, it's quite accurate. It could be even like 50 meters, so pretty accurate. But if you're in a rural area, it can be even 5, even 10 kilometers. So not a very reliable system. That's why maybe 20 years ago, I don't know exactly when, something called cell ID databases started to appear. And now I want you to imagine something. Instead of using just these towers, you're going to use the signal strength to any Wi-Fi around you. How many Wi-Fis you see here? If you open up your phone, probably you're going to get 10 or I don't know, many Wi-Fis. What people have done, and I believe it started with Nokia, I'm sure Google has done this also, they basically go on the streets and see what Wi-Fis they pick up and record their location and a fingerprint coming from how many Wi-Fis they see and what is the signal strength from each of those. So with this kind of database, they enhance, they make artificial cell towers, more of them, so that the accuracy becomes better. That's basically the idea. So 2 ways of doing positioning so far. You have the cell tower and you have Wi-Fi based positioning. Now, finally, we go to talk a little bit about GPS. I hope this works. Okay. Yeah, this picture, I don't have it written here, but it's from Wikipedia. If you Google something about GPS, then you're gonna find it. I think it's yeah, I think it's nice. I think it's a nice tool, and it's actually interactive, but it works with mouse hover. So if I click something, you're actually going to go to some Wikipedia page. But if you hover it, you're going to be able to highlight where different things are floating around the Earth. They're not just floating, but they're actually moving. And you might be surprised that this ISS, the International Space Station, it's quite low in orbit. It's actually about 300 kilometers above you. So that means that on a good day, Helsinki is farther away than the ISS. So, yeah. Anyway, that's one thing. Then you have the Hubble. It's also quite close to Earth. Some other things you can look at later, but you can see that GPS is actually quite far away into space compared to these other things. So this is where the GPS satellites are. There are many of them. I think there might be about 30 today. They're constantly taking them on and off, so the exact number I don't know for sure. They started with 20-something, and they were spread so that they guarantee a line of sight of at least 4 satellites from any point on the globe at any time. So they have a configuration that is helping that. Now, these ones, I have to say I don't remember exactly, but you can click the links. They are also GPS satellites from other countries. I think Galileo might be Russian. No, European Union. Okay, so this is Europe's. This one, maybe China. Yes, very likely. Okay, and I think this one is the Russian one. Yeah. So anyway, you can check this out. It's quite interesting. And okay, one more thing that, just out of curiosity, this is quite interesting. This geostationary Earth orbit. So if you look here, you see that this ISS is really, really moving, like very fast. Very fast. Because if it would move slower, it would fall. There is an exact relationship how high an object is and how fast it has to be moving to be keeping its orbit. If it's going to move faster, it's going to go into space. And the farther you go, the less speed you need to move. But there's something quite special about this distance, is that the object that is moving at this distance has to move with the exact speed that the Earth is rotating. It's just a relationship. At this distance, it's the same speed. So basically, you could have a satellite orbiting exactly above your head or about your house every day, if you need to. And that would be that orbit. And there are some things at that orbit, usually weather-related satellites. So if you have a company and you want to have very good weather observation in Joensuu, you want to have a satellite that is over Joensuu all the time. So you can always monitor that city. All right, anyway, these are very general things, but I think useful to know about. And here we have also a small demo about how the satellite positioning works and how it is different. It's not really any different than the other one. You have the satellite, you have the Earth, and this satellite is constantly emitting signals. It's constantly sending signals every fractions of a second, very, very often. Now, your phone has a receiver, receives these signals, and it's going to receive a signal from the satellite at some time. Maybe, let's say now, it got the signal. Of course, now it means that you can be anywhere on this surface of this big sphere. So you can be in the space, or if you know that you are on the Earth, then you're going to be on this circle that you kind of see highlighted here a little bit. So, okay, it doesn't work. I can't draw on this. But yeah, so that kind of circle that passes a bit through Africa here and covers Europe and half of Russia. All right, but of course you're going to need a second satellite for the positioning. And again, you're going to get some kind of signal from that one also. And now the place where you can be, if you also know that you're on the surface of the Earth, it basically became smaller. It became even more restricted. Now you can be in any of these 2 points where the 2 circles on the surface meet. GPS works in general. It works if you're on the Earth or if you are above, if you're on an airplane, if you're even in the ISS. So GPS is not only going to work for positioning things on the Earth's surface. That's why you need more than 2 satellites. You need the third just for this knowing on the Earth. And the 4th satellite is needed so that it works everywhere. The 4th satellite actually does more complicated things. It's impressive how this technology works, because a lot of past research goes into making this system. Like you even have Einstein's relativity going here, because time for you on the Earth is going to move slower than for the satellites. because the satellites are moving faster. It's something called time dilation, something to do with the speed that you are moving. And you might ask, why is that even important? Well, this 67 milliseconds it takes for the signal to go at the speed of light from the satellite to the Earth, that very, very long distance that we saw before. If you're gonna have an error of 1 millisecond, you might as well be on the other side of the Earth. So you want to be extremely accurate in your calculations. There is so much physics and, yeah.
Is the signal of the satellite going at the speed light?
Yes,
Really?
signal of the satellite goes in this, with the speed of light. So basically, if you're going to make errors in this calculation, now think today how many things do errors in your everyday life, and how much your browser gets stuck and you wait a few seconds. Well, here you can't wait a few seconds. You have to be very, very precise in your calculation. So when we use now, we will make a demo where we find out the GPS location. We will write a few lines of code and we will get it. But you have to remember that a lot of effort has been done so that you can use this so easily there. So even though you're writing just a few lines of code, you're working on a lot of work. Like you're building very complex applications, even if what it's doing is telling you where you are. So you can read more about this, but I'm not going to go into more details. If you are very curious, I can answer questions by email.